Okay, so now we're going to have a look at what we call rate of change. So it's basically asking you to work out the gradient at a point. So what we're going to do is we're going to differentiate a function, and then we're going to substitute a value into that differentiated function, and that will tell us the gradient at that point. Okay, so it could be asked in a really simple format like this one here. So you're given a function and you've been asked to work out f dashed of 2. So what you would have done previously back at National 5 is that you would have just worked out f of 2, and you would have substituted 2 into the x variable as it is. But because it's f dashed of 2, the first thing we need to do is differentiate that. Now, it is in a form that we can differentiate. There's no fractions, there's no roots, so we can just go straight ahead and differentiate that. So it'll be 4 times 2x, and if I reduce the power by 1, that'll give me 2x cubed. So 8x cubed. So now what I want to do is substitute 2 into that. So I'm going to work out f dashed of 2. So that's going to be 8 times, don't know why I'm writing 8 there, times 2 cubed. So 2 times 2 times 2 is also 8. So that gives me 8 times 8. So the answer is 64. Okay, so what that looks like, if I've got 2x to the power of 4 as a graph, you know, I'm not even going to draw that. I'm just going to leave that. Okay, basically we've differentiated and we've worked out, you know, a gradient at this point here where x is 2. We've got a straight line and the gradient is 64 at that point there. Okay. It could be asked in a slightly more complicated way. There could be a little story that comes around it. So we're going to calculate the gradient of the slope at d equals 4, and the function that I've been given is h of d equals 4d take away 2d to the 3 over 2 all over the square root of d. So obviously it's a much more complicated function to begin with. So the first thing we want to do is write that in a way that we can differentiate. So I'm going to do a couple of things here. So I'm going to split it up into 2 fractions, but I'm also going to write the square root of d as d to the power of a half using my rules of indices. And then what that's going to do is it's going to help me simplify this a bit further. So when I'm dividing, we subtract. So 1 take away a half is a half. So this is going to give me 4d to the half here. And then this will be 2d. So 3 over 2 take away 1 over 2 is 2 over 2, which is 1. So that'll be take away 2d at that point there. Okay, so now it's in a form I can differentiate. So that's what I'm going to do. So that'll give me a half times 4d. Now a half take away 1 is negative a half. And if I differentiate 2d, I'll just get 2. Oh. So that's going to give me 2d to the negative a half take away 2. Now, I'm going to want to substitute a number into this, and without a calculator, I don't want to work with a negative power. So I'm just going to rewrite that as 2 over, and it'll be the square root of d on the bottom, because it becomes d to the power of positive a half, and then that becomes the square root. Okay, so I'm running out of space there, so I'm just going to continue this over here. I'm now going to want to work out h dashed of 4. So I'm taking my answer to my derivative, and I'm putting the square root of 4 in there. So that'll give me 2 over 2. So that's 1 take away 2, so my gradient here will be negative 1. Okay.